final day, go.
Hi, Joyce.
Ready? Hi, Joyce. So, section 8.4, which is really kind of 8.3b and 8.4. Sorry, Joyce, I figured out what you were talking about yesterday. And yes, I put in a volumes question to begin homework, kind of as a circular review. Then it goes into surface area, then it goes into arc length. So that was the right assignment. I apologize. Okay. This is endeavor number 9. This is endeavor number 9. Now, question.
Yo.
Doesn't the apostrophe go first?
Yeah.
Oh, yeah. It's a rough day. Endeavor. Okay. Our final endeavor of the semester. And the final one you need to have down for Monday. With all of your correctors. Okay. P.S. Bring all of your cards updated.
Yay.
Question. Looking at this and thinking about this object's surface area, and then thinking about a frustum, which is this figure right here. It's the shell, it's kind of like the surface area of this band that has a slant height, has 2 different radii, an outer and an inner, and technically all the ones in between. If this formula, S, capital S, sorry, I apologize, I know it's awkward, little s and capital S, but it's true, S for surface area, little s for arc length, if you want to call it SA, I don't mind. If surface area equals 2 pi RL for this band, question, where does the error come in? Because in everything that we've been doing, whether it's discs, whether it's washers, whether it's cylindrical shells, whether it's area under the curve using rectangles or trapezoids, if a function isn't linear, there's error, unless someone makes it mathematically incorrect like this illustration right here, right? This should have error, but it doesn't. Why? Because they shaved off the ends. They should have been just like jagged ends instead. So sadly, besides that mathematically incorrect representation of cylindrical shells, mathematically there should be error. Well, where's the error? I know.
The arc length?
What do you mean though?
Well, because is it exact? Our arc length formula?
Yes, our arc length formula, the integral of the square root of 1 plus f prime of x squared dx. With an integral, it's exact. With
Because isn't it still just a bunch of estimated?
without the integral, yes.
Oh.
So even arc length has error also because it'd be lots of little fragments put together. Does that make sense? So it wouldn't have that perfect smooth curve. But since we're getting those fragments infinitesimally close, then in essence we are accumulating perfect arc length, or we're at least, yeah, we're accumulating perfect arc length. So where's the error coming in? About rounded.
Maybe we round off to 3 decimal places. She wants to know where that comes from. If you're talking about like what component,
Yeah, what
gives you the
component
error, right?
causes the error?
So like the radius or the.
Because like in rectangles, we can see it jutting out. In trapezoids, we can see it like slicing under or slicing over. Like we can see the error. So where's the error coming next?
Maybe the dx or dy, the thickness of the
dx dy
thickness of
allows us with the integral to get infinitesimally thin, so then to get rid of the error, ultimately. Right here. Do you guys see the illustration? It's very slight. It's very slight, but there's still error. Why? A frustum has L being linear. However, if you're dealing with a curve, technically, shouldn't there be a little curve to that? So this is where error occurs. Kind of like a trapezoid. And why does that make sense if we put together the idea of a trapezoid and a frustum? They both have 2 different heights. True? With the frustum, we talked about 2 different radii, because that's ultimately what we're talking about with the surface of revolution. However, like a trapezoid, it has 2 different heights. Like a trapezoid, it's going to be a lot closer to the curve, but it's still not going to be exact. It's still not going to be perfect. So it's a good idea, and it looks perfect, right? Like, look at this illustration. Doesn't that look like it's perfectly going, right? Like it's perfect. good, but a frustum is not curved. It is a surface of revolution, so in that sense it's curved, but the actual length, you can kind of see it here. You can see it much clearer here, there still is some error, and so that's why we need to go ahead and accumulate infinitesimally thin frustums. Infinitesimally thin frustums with our differential in order to be able to get the exact surface area. So anyway, a frustum, I was curious if you guys would figure out where the error was. Because the frustum is, linear, and you are taking the surface of a solid revolution which is defined by a curve, that's where that error comes in. Question, why do we only have one radius?
The average of them?
Well, that's one thing.
Oh, because that's at one.
Because if we're thinking about our figure, we're thinking about top minus bottom, so we could go ahead and accumulate all the different top minus bottoms throughout, and we don't need to do two separate, because if we're making them infinitesimally thin, we're doing the impossible. We're figuring out, like with the area of a rectangle, there is no area of a rectangle with a base of 0. So what does the integral do? Approach 0. There is no area, surface area of a frustum when the L is 0. But if we're able to accumulate with integrals doing the dirty work for us in some senses, so we don't have to actually do the definition of an integral, then in essence we can really just talk about one radius. Does that make sense? Because as they get infinitesimally thin, there is no need to distinguish between the two. Because the two will converge to each other, kind of like with slopes of secant lines and slopes of tangent lines. The tangent line is based on two separate points of the secant line converging to one point of the tangent line. Same thing here, the two different radii are converging to one, so we only have to deal with one. Otherwise, all we have to do is just plug in 2 pi RL, arc length formula for L, and then we got it. Because the arc length formula will go ahead and help us with. And remember, arc length in and of itself is linear as well. But when they get accumulated infinitesimally thin, then that makes it perfect as well. So this dx is going to help us with this r, making that useful, and then this arc length making that useful as well. But long story short, question. What's the difference between in terms of x and in terms of y? Uh-oh. Can we just pick the one that we like, or does it actually need to be somehow, is it defined by the problem that we're given?
Yeah.
How is it defined by the problem that we're given? What do you notice?
It's in terms of x or in terms of
Is in terms of x or in terms of y based upon,
Orientation.
we have revolution again. So since we have an axis of revolution, then we have to consider the differentials and the orientation. Does that make sense?
Parallel, right? Parallel.
No, because our bands are perpendicular. So if you look at your band, it depends on I see what you mean. But since we're going around a horizontal axis of revolution,
Just because out there it says a shell, like the solid revolution.
well, it is the shell. But remember with cylindrical shells, the thickness isn't the shell component. The thickness is the actual, right? It's that's why it's parallel, is because the thickness is here, even though the shell is going around. But if you think about it, think about what we did with discs and washers, right? For a disc or washer, wouldn't we have the thickness being perpendicular?
Yeah.
So we have it being sliced, in a sense, sliced perpendicular by taking the band perpendicular. So it corresponds with dx or dy in the sense of with our discs and washers.
So for this, can we call it perpendicular?
Yeah, you can technically for surfaces. Is there another way to incorporate perpendicular? I don't like that one. All right, so let's go ahead and get to an example, huh? Boop. Ah, there's no picture. Set up and evaluate the definite integral for the area of the surface generated by revolving. Hey, remember, I'm doing one final note check and one more check, so we will be on top of things. It'll be during your forever and ever final on Monday. Okay, sounds good.
What's so good about
Without accountability, we're lazy people as a whole, and myself included, so I bring in accountability because I care. Okay, so, set up and evaluate a definite integral for the area of the surface generated by revolving the curve about the x-axis. Guess what I already did for you?
You did the line for us.
Yeah, the line of what?
The other
Who's
point.
2 square root of x between 4 and 9? That is.
What? You said
Where is he revolving? You're welcome.
X-axis.
So dx or dy, right? Because we would slice it perpendicular and that would be a dx. And what's going on? He's revolving.
Revolutionary. You'd have to draw. Yeah, like that. No. Yes.
How do I show that between a band and a volume? I don't know. We'll just pretend. Okay, anyway.
What's hollow? That works.
Yeah, that's true. I'm not shading it in the big part.
That could be a washer.
I know.
No, it's not a washer.
Or you say it's an infinitesimally thin washer. Ooh, that's interesting. Anyway. So what's our surface area, big S, equal to? 2 pi integral. We know our bounds, x bounds 4 to 9. We need 2 pi r l. So we need radius. What would the radius be?
R of x 2.
Top minus bottom, yeah? Times L.
1 plus.
What's your square root?
Root. Sorry, I had written it already.
1 plus, bring down the 1/2, the 2's cancel, x to the negative 1/2,
No, we have to
whatever.
divide.
Wow,
What happened
slowed
to
that down.
Negative 1/2. Boom, there he is. Can we solve it by hand? Sure, why not? But we've had to talk, right? Good times. Like you could solve by hand
Oh.
possibly, but then some of them, if it wasn't possible to solve by hand, it would be on the non-calculated portion, et cetera, et cetera. Is that good?
It's great.
Okay, so we still have to visualize radius, but as long as we know what's going on, as long as we remember around a horizontal we're doing dx and around a vertical we're doing dy, like discs and washers, hopefully not too bad. So, no, I only gave one, oh, there you go. You're welcome. Ready, set, go. Your turn. Why are all my examples down there? Come back. Ooh, that looks fun. Sorry, there you go. I don't know why all my examples going off. Set up and evaluate the definite integral for the area of the surface generated by a revolving curve about the y-axis. Ooh,
Let's
the
say
y-axis.
axes. Let's say axes.
Well, that's for plural though.
Oh, is it?
I think so. Because axis is singular,
Oh, you're right.
and then axes would be plural. You guys like Sean Durkin and Piggy, the show QED?
That's mine.
I thought you did the rubber ducky.
No, well, I didn't do the QED. The QED I did swag, but that's my piggy.
That is not
Small
like
circle,
a
small circle,
E.
bigger circle. Small circle, bigger circle. Half circle, bigger circle. W, W, E. One coin.
Oh, that was E, E,
W,
E.
W, where does it say that?
The W are the
The
feet.
feet.
W, W, E, E, E.
But there's only 2 of these.
It's E, one coin.
I don't know if he's saying the song. And George does E, oink, oink, it's an E.
Yeah, because it's a baby.
Because the big only has one little story.
That's a big sound. I should know. I had to look them up for Luigi 17.
The girl does not have.
Or here. Yeah, you can close.
And you made it specific, so this one I would say try to be. You don't actually have to think of it without using the other ones, just like in general, you have a constant method function, so this one.
Miss B.
Huh.
I'm projected to lose in my fantasy league.
I am too.
No, but this one's like a lot of money. I'm sorry.
This is Georgie, why we don't gamble.
No, see, it was half and half me and my mom.
So you're throwing away your mom's money too. That was-
Yeah.
Try.
So that's why you should never gamble with someone else's money.
What is
Isn't
he
that the
gonna
whole
do,
premise
kill me?
of Casino Royale? It's like the whole premise of Casino Royale. The guy's gambling there because.
Or we could just
lost
pray that
money.
Michael Crabtree scores like 7 touchdowns tonight.
I'm not sure if God necessarily should bless a prayer for your own monetary gain.
But you see, the thing is, I need Michael Crabtree to score 7 touchdowns, but I need the Chiefs to score 8. So that way the Chiefs
But in
win.
his grand plan, he might, remember when he's doing one thing, he's doing a million things, so that might not be the best thing for everyone.
But for me, it would.
Ah,
Ah, behind.
that shows where,
But wait, why do we need to draw the picture?
you don't necessarily.
Because it wouldn't be, well, we're assuming it's against.
But what if you're revolving about something other than an axis, you know what I mean? Then you might have to deal with where to do subtraction and
Can we go
stuff.
absolute value of it?
Probably.
Oh, I messed
We
up.
know dy, right? What does my figure look like?
I messed up. I messed up.
Upside down. No.
Right.
Yeah,
Oh,
upside
it's a
down parabola, right?
minus.
It does it?
Yeah, it would be an upside down parabola.
Yay.
Dumbo, I messed up.
You don't gotta tell us twice.
Good, I did it 4 times.
Because we could rewrite this as negative 1/4 x squared plus 1, right? That might be a little bit easier way of visualizing it. Which means it's shifted up 1. It's vertically like squished a little bit and it's upside down. Couldn't you also figure out the intercept really fast by plugging in 0?
No, it's supposed to be wide.
And 0
Right,
is going to be,
that's-
Negative, we're at 1.
That's right,
One.
right now.
then I need 1 and 2 because in my interval, 0 to 2. So I could just plug in 1, which would go ahead and be 3/4.
The y plus 1.
Yeah.
And then if I plug in 2, then I have 0.
There we go.
That should be a little bit more curved, but that's okay. And he's revolving this a bit.
Yeah. It's gonna be like an upside down bowl.
4 plus y.
It's a paraboloid.
Oh, gosh, it's so
Am I right?
That's a better band. I like him better.
Is it paraboloid?
But not a volume, but a surface area.
Recalculate.
Okay, so what do you guys do? V
Is
equals.
it in terms of y?
Good. 2 pi in terms of, what are my y bounds?
0 to 1.
0 to 1.
Oh, wait, why?
There are 2. Oh, well, really?
Oh, I need y bounds.
Wait,
not
are
x
we
bounds.
volume or surface area?
Ah, surface area. Oh, sorry, thank you.
Okay, so it's y minus y.
Those are the easy mistakes. They want a tricky one.
Those deals about people.
X is minus
Wouldn't it
y
be a
plus
0 to 1? Oh, yeah. it is.
Yeah. What's my r gonna be? Right
Top
minus
minus right minus left.
What if we were going about instead, x equals -1?
Then we would have x equals -1. It's over there. Still right minus left. but-
Yeah, but it'd be function minus -1, so plus 1, right?
Yeah.
Okay. So then function, plug it in. No, I need it in terms of y. So therefore we need to go ahead and subtract y and then divide by negative, which would be -1 minus y. And then I need to multiply by 4, so that'd be 4 minus 4y. Then I need to square root both sides.
Wait, what are we doing?
Getting it in terms of y.
Oh, it's not. Dang it. I just realized.
Struggle, huh?
And you need
Double check
y.
my work though. Y minus 1, flip it, 1 minus y times 4, 4 minus 4y, square root.
Could we pull out the 4
Yeah, that's what I did.
You could if you want to.
and then it would be 2?
If you're doing this by hand, yeah, right?
Yeah.
Square root of 4, that would just be a 2, so we could do the 2 square root of 1 minus y. But that's the radius, and I still need the square root of 1 plus. Ah! Derivative of who? Of him.
3/4, -3, not negative 3/4, -1/2 x.
Then we're just gonna do x prime, so we take a derivative with respect to whatever we have.
Oh, no, it's
The
expensive.
2 is on the outside, then we bring down the 1/2, and then we have a -1/2, which will be a square root of 1 minus y, and then we have times u prime, which will be -1.
That's
Double check
Remember
that.
I have the original y equation?
yeah.
I was waiting for her to drive because I was not going to drive that.
What? You just bring down the 1/2.
I know, but I didn't want
He's
to do it
under
faster
And
than you.
-1/2.
Miss D, he's under the influence. He's not gonna derive under the influence.
He's got a point. I had some morphine this morning.
That's not what I was gonna say, but you said it.
Wow.
so.
Okay. Don't know how to respond to that one.
Oh, come on, George can joke about other stuff. You guys get that one.
Okay, well, it sounded factual.
And she doesn't usually laugh at my jokes.
Also somewhat true. I should shake my head.
Yeah.
With a smirk.
And
What am I doing right here?
George, bad.
Oh, there we go. Yeah. Were you able to finish it okay?
You want to score it?
And then let me give you your notes.
Negative minus square root of-
You're gonna score her forever quiz?
Yeah, I'll do it with my eyes closed.
Forever final? Eyes closed. I'm not sure it's gonna be very accurate.
You don't have to be accurate, just have to be graded, okay?
If only I took that approach.
I would love that.
1 plus, wow. Okay.
Sam, we got it?
I need 15 points to come out of nowhere, guys.
Oh, that's yours. I was like, oh no,
I don't think Stephen House is gonna give me points.
I didn't put it in because you didn't make the square or
For our parentheses. Wow, that was pretty fast. 15.318.
Misty, can I still see motion? Wait, are we still doing, are we supposed to be still doing the same problem?
Because I think this is the answer.
No, it's just set up and evaluate.
We don't look at
Alright, cool kiddos, do the next one.
Flip the page.
I did.
Oh, no. You see this one though?
Sunshine flower.
What's the zone of a sphere?
Huh? The zone of the... Wait. This is a semicircle. So like, the zone must be the surface area of the sphere.
Oh,
Right?
okay.
Sure.
We'll go with zone is the same as surface area.
What's a zone?
Of the zone, it's like the area of the thingy.
Surface area?
Of a sphere, right?
Well, like it's asking
It's
for...
just a snazzy way of saying it.
Yes, first try.
First try, but you have to ask more times. You said that.
Remember, I did first.
I'm just question what like the mathematical definition of zone is though.
I just think they're cool because they can use words to start with.
Yeah.
They get 10 extra.
What's the mathematical definition of zone? Mathematical definition of zone. She's not working. Mathematical. Nope.
Does that turn off your mic? Bye, Carla. Merry Christmas. Happy New Year.
I was
Merry
Bye,
Kwanzaa.
kid.
Thank you.
Don't do drugs. Unless Mystique gives them to you.
Bleach maybe?
Dang, she went there.
A portion of a sphere between two parallel planes intersecting the sphere.
A sphere?
Huh.
Oh, I can't just...
Let's do Wolfram. I trust Wolfram a little bit better than...
What?
Oh yeah. Okay, so a zone is just a portion of the surface area of a sphere because they only gave us between 0 to 2. And this has a radius of 3, so it's not going to be the entire part. That makes sense, right? Okay, maybe not.
No,
Never mind.
because they give us both sides. I mean, you just need to give us
Give
one.
us both sides, they only give us the top.
But it's revolved.
No, but that's what I'm saying, it's a zone. We're gonna give us the top.
Okay, let's say it gives us one.
Yeah, so it's 3, right?
Yeah.
They're saying revolved about the y-axis. So right now it's a half sphere, true. But it says only use between 0 and 2. So we're only dealing with this. Zone. Does that make sense?
Forgot about the 0 and
Oh, there you go. So then what do you guys have? S equals 2 pi. Any rule front?
9 minus 4.
Oh, struggle. Hold on.
Wait, yeah, that's not.
I did the wrong way. I did y is 0 to y is 2, didn't I?
Can I be nuns?
So we have to plug into to my formula, true? So then plugging into, that would be 9 minus 4, which would be, the square root of 5? square root of 5 would be 2-ish, but a little bit higher.
2.2.
So we'll say x is 2 is right there. So our zone's a little bit higher than 2-ish. And the picture is still very similar, but
Wait, but is
we
it,
need to go from 0.
shouldn't it just be,
No.
because you have all the way to x equals 3,
But root 5 is a y bound, or
No, because 3 is up here.
but it's from x, from 0 to 2.
Uh-huh. So then I went ahead and figured out when x is 2, what does y equal, and I plugged in
So it's from 0 to 2, so it's just the top section.
0 to root 5. Because I have to do dy, right?
But the shaded part should be the top.
Because an x equals 0, y should equal 3.
Oh, I see. Sorry, I wasn't realizing what you were saying.
It's okay,
I'm still going in Ys.
I don't really know what I'm saying either.
Well,
No, you do.
I don't.
What if you say the wrong thing?
And I,
Hold on. So we have our
because
2 red 5s. The division is right,
it's the top part.
but it's the top part because it's from x is 0, which would be 0, 3. So it's going to be from root 5 thinking. I was still thinking in terms of,
why is it in terms of y bounds?
there we go.
Because
Do you want? Sorry, I should, because we're going around a vertical axis.
I wrote.
There we go. I was still thinking lines there too.
Oh my goodness.
so what about the last one?
About the y axis.
What do you mean the last one?
Last one uses the bound of x.
That was okay though, because it was
No, we changed it to y.
0 to 2. Oh, because this one was the entire portion, right? Because x, when x is 0, we have 0, 0. And then when x is 2, we have 2, 0. So it was the entire thing. And the entire thing would be from y 0 to y as well. Does that make sense? Oh, sorry. That's not 0, 0. Obviously that's 0, 1. There we go. So the y range is 0 to 1, whereas in this one, the y range is root 5 to 3. My radius, if I was doing my frustum, my radius would be from, ooh, but not that side, right, to the positive square root. So do the positive square root to the axis. So then we would have our function, which would be in terms of y, which would be y squared, 9 minus y squared. Is that right?
So square root of 9 minus y squared.
Oh, because it's x squared.
Question?
With the sphere. Uh-huh.
So, the shaded part that we're revolving is only in the first quadrant, right? From 0 to 2.
What's being involved then?
Yeah, that's why the other side is shaded.
Exactly. So we get down to the derivative. So I take the derivative, so you need to bring down the 1/2. Make it negative 1/2 times u prime. The 2's would cancel, right? So I'd have negative y over the square root of 9 minus y squared. Does that sound good? Double check me out. Bring down the 1/2. Negative 2y, that cancels. Negative y over square root of square root. Okay. And if you guys notice, this one could totally be done by hand. Well, maybe I shouldn't say totally. More easily done by hand because these are going to cancel eventually. Because the square root's going to cancel, but it's still under one big old square root, so those denominators will go like that. We're still going to have 1 plus y squared, which you have to solve with trigonometric substitution that we don't know. Struggle.
We don't learn that.
We haven't needed it for the BC. Yeah.
If we're gonna plug it into the calculator, do we just use x as the y?
Totally fine.
Okay.
Because you've already resolved the functions in terms of the variable you need with the bounds that you need that match up, but when you feed it to your calculator, you're just saying, hey, this is a problem, I need to solve it. The dilemma why we have to be super careful up here is because the x's will have different bounds and the functions will look differently, et cetera. But once we're going to our calculator, we're saying, no, just this formula. Who cares if it's y or x or a or b or t? Gerardo. Oh, sorry.
I was just gonna ask, you know it's that area because you're revolving, because you're revolving that,
But-
the arc length. You're revolving the arc length, right? That's why you know that's the area, not below it.
Yes, you could say it that way. Well, no. The reason we know it's not below it is because it's between x's 0 to x's 2. So between x's 0 to x's 2 is all the values between which y will be 3 to root 5.
And that arc length is being revolved.
Yes. But I think the reason, because you're trying to resolve why it's not below, that's all to do with the x values. Okay. Last one, except it's a little bit funny, some of my things got put out of place.
Place.
No.
Above.
There we go. It's different versions of smart software, I think that's the problem. Alright, last one. Here we go. Let R be the region bounded by y equals 1 over x, the x-axis, x equals 1, and x equals b. Where b equals, or no, b is greater than 1. D be the solid form when R is revolved about the x-axis. Find the volume. This is going to have us review everything. You guys visualizing? This is an interesting problem because this figure they are stating, according to the problems, has a finite volume as you go to infinity, but an infinite surface area. B is greater than 1, so B equals 0 is not. Does that make sense? Or sorry, x starts at 1. But you're right, there is a vertical aspect of this too. How can a figure have a finite volume? Of an infinite surface area. This figure is actually called Gabriel's horn.
Why is it confusing? Thanks.
It's old. In the olden days, they were sort of biblical references that were popular in culture. And when you graph the figure, what does it look like? A horn. This is actually the BC sweatshirt the very first year.
Oh, is that what it was?
What part of? It had all the math showing these two figures.
Yeah.
It's like, what part of? Don't you understand?
Oh, wasn't that so bad? Oh, that was another freshman one. I thought it was really cool.
Okay, so what do you have so far for letter A? How do we find volume? Discs or washers?
This.
Because we revolve, isn't that flush? So we're gonna go ahead and have B equals, well, we're revolving around the x-axis, dx or dy.
DX.
So I, integral from 1 to b of r, which would be top minus bottom, right? Squared dx. Have we expressed it? Yes. If we were to solve it, we would have to go ahead and say, okay, integral of 1 over x squared. Let's go ahead and do this one right here. What do we got?
1 over.
Add 1, right? So x to the negative 2 plus 1, negative 1 over x. Does that sound good?
Yeah.
Does that make sense? Is x to the negative 2 plus 1, negative 1 divided by negative 1?
Well, the square.
But we're integrating.
Oh.
So x to the negative 2 plus 1, negative 1. It's been too long since we did it by hand, huh?
Where is it from?
What's it gonna
Be on the pen, like chapter 8.
In lieu of having like a full chapter 8 test and then a final, I'm just
Like every other
incorporating it.
teacher.
It usually doesn't have that, I don't know why this year.
I don't think Mr.
I think it's because there's a week shorter in the semester, so they were all supposed to get
But-
through a certain.
Mr. Will said like, cause don't you have to turn in your final to Mr. Halliday or something to get have him checked? Don't you guys have to turn it into someone?
Probably.
Well, yeah, he turned it into Mr. Halliday, and I guess Mr. Halliday said he can't do that.
Can't do that.
Like, put our unit test and our chapter test with the final.
I mean, I don't do that because it's just, chapter 8's gonna be 1 of 8. It's gonna be on there, that you guys have to do the test, but other teachers don't do that. That's weird. Anyway. Good job. Democracy used to be fun. Okay, so. Finish solving, and then we go ahead and plug in B, and we have,
But what's B?
well, our bounds. F of B minus F of A, this one's gonna be minus, that's gonna be a positive, this one's gonna be a negative. So I'm just writing it this way. We're gonna go ahead and have times I.
F of B.
Will be a negative B over X. Oh, no, yeah, negative 1 over B. Negative 1 over B minus 1 over 1. Struggle, sorry. And I just wrote it the other way because I have the negative 1 being second. So negative 1 over B minus 1 over 1, or, sorry, minus a negative 1 over 1. There's my volume, or an expression for my volume. For my surface area, how are we going to do that?
S equals. From 0 to, from 1 to B, I should say.
Where's that in?
And R equals
Oh,
2 pi, sorry.
let me put B. Put S.
Integral from 1 to B.
We're gonna have our radius, which is B top minus bottom, right?
1 over x.
Times.
1 plus.
Now take the derivative, so negative 1, bring it down. Wouldn't that be negative 1 over x squared?
Yeah.
Which we go ahead and struggle to do this after substitution. That'd just be plus 1 over x to the 4th. Which would be x to the 4th plus 1 over x to the 4th. Is that right?
You pull out the x to the 4th on the bottom, right?
You make it like a square root of x to the 4th, so x squared, and pull it out, so 1 over x cubed.
Square root of x to the 4th would be x squared, right?
Speak a big piece, big sub. Aww. Let's leave it for now. For letter C, when it says as b approaches infinity, then we can go ahead and just say the limit as b approaches infinity of b would be of pi times 1 over 1 minus b. Sorry, 1 minus 1 over b.
Which is the volume.
So it would be the infinite volume of Gabriel form. It converges because 1 over infinity would be 0, so then it would just be I. True. And for letter D, sadly, we'd have to go ahead and take a limit as B goes to infinity of capital S. Should have all wrong. Yes.
What is it with the bell in this?
My room's not working. I have emailed the appropriate people and they just started ignoring it. Bye guys, see you later. I know. Bye, Misty. Bye guys.
Hi, Miss Dave.
Nice thing is you guys won't have to solve an interval like that by hand
Homework
and
is
homework.
due tomorrow though, right?
Yeah.
Hey, Miss Steve, are you in like charge of it? Do you actually? Okay. So like you'll be going on it?
I'm going and